Hello, my name is Chibuzo Njoku, and I'm in the master's program in business analytics at the University of Colorado, Denver. Currently, this is an assignment on finding a model that seeks to optimize either um, maybe profits or operations, or rather optimize operations in order to either save on costs or increase profits. So I found the vehicle routing problem, even though it's a problem, it could also be modeled in a way to um, sort of help either logistics operations, and that's why I found it really interesting. Um, I I first discovered this model in a project I was doing with um, trying to optimize for delivery systems in e-commerce companies like Amazon or Jumia. And so I have a background in physics, and I'm also interested in, or I'm majorly interested in vehicle routing optimization and programming techniques. I expect to learn about optimal decision making through this assignment and all through the course. Um, the course name is um, Prescriptive Analytics by Optimi or for Optimization. So here's an overview of what I'll be talking about. So I'll go through each one of these items, starting from the nature of the application down to the benefits of using this model or solving this problem. So the nature of this program or this problem can be seen in most companies that have a delivery process or element. Companies like maybe Amazon or um, US Postal Mail, even Walmart. They use some measure of the vehicle routing problem to solve for food um, management. Um, so it could vary across depending on the type of services you could apply this to, from food delivery, package delivery to mail delivery. And it usually has to do with the vehicles, at least the vans you see. And the whole point of solving this problem is to route those vehicles optimally. That's to route them in the best direction, taking the best route, and minimizing the time they use to operate or deliver items. So in terms of who did it, so there are a lot of people that have done it and that are currently doing it. So there are a lot of major players in the industry that are using or solving for this problem and have created different kinds of models to help ease this problem of the vehicle routing problem. There are also other similar problems or ones that are related to it, like the discrete choice model and the traveling salesman problem and the time routing problem. There are a bunch of them that could come together to even improve on this problem or this model. So you have big players like Amazon, Walmart, even the petrol tankers and their companies that um, deliver petroleum um, products. They use an optimal routing process to make these deliveries or load these tankers. So there's also UPS and US Mail. So the features in this problem vary. There there are a lot of features, and it's a really, it's not just one problem, but you could say this is a segment of the problem, and this is still very, it's still huge. It covers a lot of things. So the features you would notice in this problem or similar problems, like I had mentioned before, are, you'll notice that there are numerous entity connections, and this could mean that there are connections between the drivers as entities, the companies, the trucks, the vehicles as entities, the customers as entities, maybe the payment um, services as entities, the websites as entities. So all these things are connected together in order to solve this problem, or they're connected together in this model. So you also see digitization in supply chain, and there is that element of procurement, production, and then delivery. Um, you also see maybe some talk about performance and increasing profit, also loyalty. When you would also come across inventory, you would see this in a lot of the companies or businesses looking to solve this problem or using this model. Definitely see inventory. You could talk about Amazon, their merchandise or inventory in their warehouses is, I mean, from my understanding, would be a lot. So and even the tankers I mentioned, the petroleum products, you could also classify them as inventory, the products themselves. So you also get payments and information network. So it's information that these people share and use in this model. Maybe if it's an Amazon truck you're looking at, he's using information from all the sources he can get to either route his truck in the right direction or knowing where to deliver his delivery. So you see, one of the most important elements or factors of this problem or model is real-time stakeholder needs. So, and the keyword there is real-time. So everything has to either be updated in real time in order to function properly. So it could be if something changes, it also changes in across other directions. So in case, I mean, for example, if a if a truck is scheduled for tomorrow and maybe there's a purchase that is made and the truck is supposed to go in the route the purchase will be delivered to, then it changes, maybe the first, maybe the sequence of stops he makes. So maybe instead of stopping in a particular direction, now he will have to go maybe right to go stop in another direction, just so he could make that complete sequence and do it properly or do it efficiently or optimally. And we also see a location element where locations have to be determined in order for anything to work. So I think you have to know where the delivery is going, and or you have to know where the pickup is going to be made. So you also see that most of the tools here are digitized and optimized, even in the warehouses. You know, there's a lot of talk about how workers in Amazon warehouses are made to function optimally, as the case may be, and also scheduling and routing activities. So these trucks could get routed even as they're on their route. It depends on how maybe there's traffic, or if they see another route that has opened that is even more efficient. Okay. So in terms of size, I wasn't sure how to answer this entirely, but the vehicle routing problem, when applied, is solved has the potential to greatly affect optimization across all industries and departments related to logistics, traffic management, and scheduling or scheduling activities. So here is how it's solved. Using the framework for linear programming, I think. We have a decision variable, constraints, and an objective an objective function, then the data, and then you have the algorithm that puts it all together or solves it in a way. So the decision variable represents the routing, the vehicle schedules, the driver schedules, and delivery schedules, amongst other things. Now the constraints would be the map of the city, the road circuits, the road laws, and for example, for road laws, you get maybe a one-way street. So the algorithm would have to know that the driver can't circle back in that particular street. So it would have to make those deliveries across both across the street, and not doing it and driving around and trying to go deliver on the other side, if that makes sense. So the objective function here would be time, vehicle actions, revenue loss, that's trying to minimize these factors, and then maximize performance amongst other things. So the data here would be the package information, route information, customer information like the addresses and so on. The algorithm here could be some algorithm or just some planner that makes sure that these, or it could be an Excel solver maybe. Make sure that these routes are selected optimally. And in this case, the vehicle routing problem, I'm sure they use a lot of algorithms for this. One of them I should mention could be the K nearest neighbors algorithm that helps cluster points or nodes. These nodes could turn out to be addresses and where the vehicle would pass through. So that's the bit on how it is solved. And other interesting features are like I mentioned, the K nearest neighbors algorithm. So it's used for clustering and helps gather particular locations that are close to each other. And in terms of mathematical meanings, to improve their model, it would mean that for every 4 times the if a delivery companies or a company that's making a delivery or makes delivery has their customer base increase by 4 times, it would mean that the driving time to deliver to any of these locations would increase only by 2 times, which saves them delivery time or driving time. So the next one is the benefits. There are a lot of benefits with this or solving this problem. Those that are able to form strong models to help solve these problems would be saving on operational costs, shortening operational time, improving efficiency, increasing revenue, and increasing overall performance. So these are my references, and I've come to the end of my presentation. And thank you for listening.